Hello and welcome to Cbse Fatafat by Ved Academy. This is the Cbse Class 10th Mathematics Complete Solution Series where we don't just solve problems, we build strong concepts and clear understanding of every topic. The lesson is real numbers. It is the introductory part of the lesson and we are taking the topic which is uses of Euclid's division lemma. In the previous video we have seen how we use Euclid's division lemma to prove and apply Euclid's division algorithm. Today we'll see how to use Euclid's division lemma to prove the properties of the numbers. And for that we will look at the properties of the numbers one by one. So let us start with the use of Euclid's division lemma to prove the properties of the numbers. The first one is to show that any positive odd integer is of the form 2q plus 1 excuse me, and the solution is, let a be any positive integer and b is equal to 2. When we say that a be the any positive integer, here we are taking a as dividend, and as we have to prove that any positive odd integer is in the form of 2q plus 1, 2 here becomes divisor. So we have taken b as 2 because we write the dividend or the Euclid's division lemma as a is equal to 2q plus r, where a is dividend, b is divisor, r is the remainder. So here b is equal to 2. By using Euclid's division lemma, that is a is equal to 2q plus r, where the most important condition is r is greater than or equal to 0 but less than b. Here we will say that r can be equal to 0 or r is equal to 1, as it is less than 2 here in this case. So now we will deal with two conditions one by one, by placing r as 0 and by placing r as 1. So case 1, we have r is equal to 0, then we will write a as 2q plus r, replacing r with 0 we have 2q plus 0, so a is equal to 2q, but this represents even number as it is divisible by 2. So this is nothing but the even number. We are talking about the odd integers. So we will move to case 2 and we have r is equal to 1. So a is equal to 2q plus r, will replace r with 1. We have 2q plus 1, and hence any positive odd integer is of the form two q plus 1. That is, a is equal to 2q plus 1. Now, let us understand this by taking example. So, we'll choose a positive odd integer. So, suppose we are taking the positive odd integer as 15. So, example, the positive odd integer is 15. As we have to write it in the form of 2q plus 1, that means here the divisor is 2. So, a is equal to 2q plus r, 15 is equal to 2 into 7 plus 1, and thus here you will see that the remainder is 1, and therefore we can write 15 is equal to 2 into 7 plus 1, which is of the form a is equal to 2q plus 1. That is, this positive odd integer is of the form 2q plus 1. We can take one more example. And we will take the example of 27. That is, the positive odd integer is 27. Now, as we are writing it in the form of 2q plus 1, our divisor will be 2. So, 27 is equal to 2 into 13 plus 1. 27 is equal to 2 into 13 plus 1. Thus, we can write it in the form of 2 into 13 plus 1 is in the form of 2q plus 1. Here, it is in the form of 2q plus 1. That is, 13 is the quotient, 1 is the remainder. This is how we use the Euclid's division lemma to prove the properties of the numbers.